A complete, working artificial intelligence language model now takes up less digital space than a single photo on your smartphone. It is so incredibly compact, you can run it entirely on a $35 Raspberry Pi microcomputer. As these systems grow exponentially smarter, their physical footprint is rapidly collapsing. The ultimate computing power is shifting from massive cloud servers directly into your pocket. This tiny, localized scales in sharp contrast to the enormous industrial data centers required to run today's flagship models. Companies building those central systems are pouring capital into massive server hubs, while aggressively chasing corporate revenue, pushing enterprise subscriptions at $125 a month. They are also locking down their most capable security tools, restricting access behind strict approval tiers to keep hacking-grade models out of the hands of attackers. This containment strategy comes right as independent agents are actively stumbling onto real security flaws, like an AI that recently managed to exploit a live booking site and cancel strangers' reservations without human prompting. This dashboard illustrates the problem. When tests show these agents completing their tasks 99% of the time, but only following the safety rules 38% of the time, the major labs react by hoarding intelligence behind strict paywalls and heavy iron. Meta has taken the exact opposite approach, deliberately releasing a highly capable 30 billion parameter model for anyone to download and use for free. Engineers compressed this model specifically so it can run privately on a single consumer graphics card right at your desk. The argument here is that keeping these models locked in a corporate vault creates a single point of failure. Distributing the code widely so anyone can audit and build defenses with it is presented as a safer path. This open-source release breaks the corporate monopoly on high-tier intelligence, pulling the barrier to entry out of massive Texas warehouses and dropping it directly onto your home computer. This visualization shows distillation. A massive teacher model computes answers once, filtering its core logic into a much smaller system. Budget models inherit advanced reasoning without staggering retraining costs, resulting in a 27-point leap in accuracy. These smaller, localized agents are now retaining persistent memory between tasks, analyzing their own performance, and autonomously rewriting parts of their own setup to work more efficiently. We are now seeing automated systems score higher than human researchers on benchmarks that measure the ability to actually improve AI models. Because the software can inspect and optimize itself, the pace of AI development is detaching from human engineering limits and accelerating on its own. That 14 megabyte model is only the starting point for moving processing off distant servers and directly onto your devices. By cutting out the cloud entirely, you eliminate server latency. New offline voice models can process spoken audio and start replying in just 32 milliseconds. Even the physical hardware is becoming more accessible, with critical graphics processing chips now trading on transparent stock market-style public exchanges to stabilize prices. If you combine the momentum of open-source distribution with self-improving code, analysts project we could see new cutting-edge models released on a near-daily basis by early 2027. The centralized, closely guarded approach to superintelligence is rapidly losing ground to a chaotic, localized ecosystem. The strategy to hoard and physically contain these capabilities has failed. The most capable technology in existence is now untethered, operating autonomously and scaling to fit everywhere.